Electric energy. It's the lifeblood of our modern world. Every day we rely on electricity in countless ways. When we flip a light switch, turn on an appliance, or power up our computers, we expect that electric energy to be there, instantaneously. But did you know that electricity has to be generated at the moment it is being used? A massive system of generating plants and transmission and distribution lines are in place to meet the energy demands in residences, businesses, and other institutions. It's a demand that fluctuates throughout the day. More power is needed in the mornings as people get ready for work or school, or in the afternoons when air conditioners are humming, or in the evenings as dinner is being prepared and lights are being turned on. These are what energy experts refer to as peak demand periods, and the industry has struggled for years to meet these peak demands effectively and economically without having to build more conventional generating plants. But what if you could store energy, created during off-peak times for use when the demand is at its greatest? What if the technology existed that would allow this energy to be retrieved quickly in a cost-effective manner? Compressed air energy storage, or CAES, is an innovative, advanced form of electric power generation. PowerSouth Energy Cooperative currently operates the only CAES unit in the nation and only one of two in the entire world. As a member-owned generation and transmission cooperative, PowerSouth Energy Cooperative provides wholesale power to 20 distribution members in Alabama and the Panhandle of Florida. Serving nearly 800,000 residential, commercial, and industrial consumers, PowerSouth's need for an efficient and reliable source of power to meet the peak load demand paved the road to this exciting new technology. In the fall of 1991, the nation's first compressed air energy storage facility in McIntosh, Alabama began operation. PowerSouth's McIntosh plant consists of a 110 megawatt CAES unit as well as two more conventional combustion turbine units, giving the plant a maximum output of around 350 megawatts. The McIntosh site is located on top of a large salt dome cavern measuring nearly 1,000 feet in height and well over 200 feet in diameter, large enough to comfortably house an 80-story building. The cavern has a maximum volume of approximately 19 million cubic feet, making it an ideal choice for the CAES process. During off-peak hours, when the energy generated by PowerSouth's larger baseload plants is less expensive, air is pumped into the cavern in a process called compression mode. At full charge, air pressure in the cavern reaches nearly 1,100 pounds per square inch. During periods of peak demand, the plant is put into the generation mode. Here, air from the cavern is released and routed through more than 1,000 feet of pipe and fed into a heat exchanger called a recuperator. Here it is heated up to approximately 600 degrees Fahrenheit. The hot air then enters a high-pressure combustion chamber, where natural gas is used to further heat the air to around 1,000 degrees before entering the high-pressure expander. The exhaust in the high-pressure expander is reheated to 1,600 degrees before entering the low-pressure expander, where it is fed back through the recuperator, providing an efficient source of heat for this stage of the process before being discharged into the atmosphere at a temperature of around 280 degrees. Together, the high-pressure and low-pressure expanders rotate the generator to produce electricity. On a fully charged cavern of air, the CAES unit is capable of generating enough electricity to meet the demands of nearly 11,000 homes for a period of up to 26 hours. PowerSouth's CAES facility provides a very efficient solution to meet our peak requirements. It not only greatly reduces the need to burn expensive fuel, it allows PowerSouth to take advantage of lower cost off-peak generation for its compression process. CAES is very cost-effective and easily competitive with other comparable peaking duty plants. While the idea of storing energy by compressing air in huge underground caverns may seem like science fiction, it is in fact a reality. A cost-effective, efficient, alternative energy reality, while PowerSouth Energy Cooperative recognized early on the importance of this technology. Other utilities have begun embracing it as the world's energy demands increase. The first CAES plant in Huntorf, Germany, and PowerSouth's McIntosh plant have blazed the path that others are now traveling. And it all starts with a huge hole in the ground.